All right, this is video 3 on argument and argument evaluation. So, big picture, what are we doing here? Uh, we are talking about a procedure or process we can use that, if it is used correctly, will give us the proper total evaluation of any argument, formal or implied. Pretty cool, right? Um, for practical reasons, what we're doing is to basically uh, follow along that little chart. There's a little one-page chart PDF, um, and that's really the goal in the procedure. What we're going to learn how to do is evaluate arguments through a series of 4 questions, and that if you answer each of those questions correctly, you will arrive at the proper evaluation of the argument. So in our previous 2 lectures, we actually covered the first 2 questions, and I hope you've been practicing with those and engaging in the discussion boards, etc. You have some group of sentences. There are 2 possibilities. Either it's an argument or non-argument. What do we ask? Does it make both a factual and an inferential claim? If yes, it's an argument. If no, it's a non-argument. In this chart, anytime you answer yes, you go upward. Then last video, we talked about this all-important distinction in inferences. Is it a deductive inference or an inductive inference? So deductive argument just means an argument that uses a deductive inference. Mutatis mutandis. So what did we learn there? Deductive arguments are arguments whose inferential claim is a claim of logical certainty. Inductive arguments, the vast majority of our arguments, are the rest. So question 2 we ask there is, is the inferential claim a claim of logical certainty? Then the last 2 questions are going to be about evaluating those 2 things that we have to evaluate in every argument, the inferential claim and the factual claim. As we learned in video 1, you have to evaluate the inferential claim first. Before we start talking about that, let me say 2 things. Thing 1, all these definitions are given in some sense in the argument summary handout. But second, there's this important generality there. And I would like to draw your attention to, on the chart, questions 3A and 3B. So both of those have an important commonality in that those are questions of inference. Cannot emphasize this enough. Questions of inference are never, are the premises true? No, what's common of both questions 3A and 3B in terms of inference is when we ask a question of inference, what we need to be asking is, assuming it were true, that is, assuming all premises were true, would the conclusion follow? So that's true for question 3A and 3B, just slightly different definition of what it means to follow. So that's where we're at. Never forget where you're at in the chart. That gives you a lot of information. So notice on question 3A, if we're on the deductive prong, our 2 terms are valid and invalid. Noticing where we are gets you 90% of the way there. The word valid applies and only applies to a good deductive inference. So if you want to give an approximate definition of valid, good deductive inference. Notice nothing else could be valid. There's no such thing as a valid inductive argument. There's no such thing as a valid coupon. There's no such thing as a valid point. But further, valid is only part of the evaluation. So should we accept the conclusion of every valid argument? No, because that just means a good deductive inference. 2 videos ago, I gave the following inference. Mickey is over 12 feet tall, therefore Mickey is over 10 feet tall. That's a deductive argument from math. The conclusion follows from certainty from the premise. And yet, do you accept that Mickey's over 10 feet tall? Of course not, because valid is not enough. And so we're going to say a lot more about validity, definitely the most important concept. If you get this, the rest of it falls into place pretty easily. So, I'm going to start with some definitions of validity. They're all interchangeable. So again, the approximate definition of validity is a good deductive inference. What does that mean? Here's 3 definitions of validity. All of them are equivalent. Use whichever one helps you the most. A deductively valid argument can be defined as an argument in which it is impossible for all premises to be true and the conclusion false. That's the one that's in the handout. An argument in which it is impossible for all premises to be true and the conclusion false. That's the most standard definition, and the reason for it is notice what it says and it doesn't say. It doesn't say the premises are true. It doesn't say the conclusion is true. It says when the when the premises are true, the conclusion must be true. It's about the relationship between the premises and the conclusion, and that's how you should always think about validity. It's about the relationship between the premises and the conclusion. If the premises are true, the conclusion has to be. So, we'll talk more about that as we go along, but let me give you the other 2 definitions for now. Another good definition of validity is an argument whose premises imply the conclusion. That is in the formal sense of imply. Once more, I like that definition because it really emphasizes this is just about the relationship between the premises and the conclusion. So, Mickey's being over 12 feet tall very clearly implies that Mickey's over 10 feet tall, and yet we don't accept the latter. So I like that definition. And a third way to define validity accurately is to say it's an argument whose form is always truth-preserving. So again, an argument whose form is always truth-preserving. Those last 2 definitions are not in the handout, but they're helpful. The reason that one's helpful, as we're going to see next video lecture, is because the form is ultimately what we're testing to determine if an argument's valid or not. So the third definition is somewhat procedural. It can tell us if an argument's form is valid, but it also is nice and it emphasizes that deductive arguments, the conclusion is just supposed to follow from form and definitions, nothing else. So any of those 3 definitions of valid will do. And later we'll just make a couple of tweaks to change from deduction to induction, so it's helpful to realize those. Another important lesson, though, and this is one we really have to take to heart in philosophy, in a valid argument, the premises guarantee the conclusion, which means if I want to reject the conclusion, I have to reject a premise. So I cannot deny the conclusion of a valid argument without denying a premise. That's hugely important for intellectual consistency. Anything else is just as irrational as saying 2 + 2 is 5. So we'll circle back to that point as well. But think of the previous example. Well, do you reject that Mickey's over 10 feet tall? Of course I do. How can you do that? Because I reject the claim that he's over 12 feet tall. It's the very basic example. But for now, let me give you a slightly more involved example, but only slightly. Here's an argument. Suppose I said the following. All Republicans are space aliens. Barack Obama is a Republican. Therefore, Barack Obama is a space alien. Is that an argument? Yes. Makes factual claims and an inferential claim. Has a therefore. Is it deductive? Yes. Notice it's an all, no, some. The conclusion is supposed to follow based on the definition of all. All Republicans are space aliens. Is it valid? And here's where I want to pause and really emphasize how we evaluate this. As I already mentioned, this is a question of inference. So we don't ask if the premises are true because that's irrelevant. It doesn't matter. The question is whether the conclusion follows from the premises. So instead, I ask my inference question. Assuming it were true that all Republicans are space aliens, and assuming it were true that Barack Obama was a Republican, would it follow that Barack Obama is a space alien? Simple yes, no question. The answer is obviously yes, which means that that argument is valid. This tells us a few things, though. First of all, notice this tells us why valid is not enough to accept a conclusion. Do you accept that Barack Obama is a space alien? All cutesy, stupid political jokes aside? Well, of course not. That's crazy. How can you do that? It follows validly from the premises. Yeah, but the premises are garbage. So I could reject the conclusion of a valid argument because even though it follows from the premises themselves are false. And so we cannot reject the conclusion without also rejecting a premise. Again, anything else is to be irrational. If the premises guarantee the conclusion and I reject the conclusion, I have to reject the premise. So watch for that, and that'll come up a lot more in the class later. So that's validity. All we ask is deductively, assuming all premises were true, would the conclusion follow? That's probably not enough. The next video will get into formal evaluation a little more, which is to say we'll learn the procedures for determining validity instead of just this kind of guessing, seems like it to me stuff. So we will get there. That's not the purpose of today's video, though. We're mainly learning the terminology stuff. So last question on the top of the chart. First of all, you'll notice it only comes off of the valid branch. The last question is about soundness. And let me say a few things here. Once more, if you realize where you are in the chart, that gets you 90% of the way there. The approximate definition of sound, again, gets you 90% of the way there. The approximate definition of sound is a good deductive argument. If you think of a sound argument as a good deductive argument, that gets you most of the way there. Because, as we've learned in the previous videos, well, every argument must do two things. It must make a factual claim and an inferential claim. A sound argument is one that does both of those well. So, the formal definition of a sound argument, then, is a valid argument with all true premises. So, let me mention a very common mistake here. The definition of a sound argument isn't an argument with all true premises. The definition is a valid argument with all true premises. Those are worlds different. Why? We could approach that in a few ways. But remember, a sound argument is a good one, which means a sound argument is an argument whose conclusion you have to accept. That's why we're doing it in the first place. So you cannot reject the conclusion of an argument that you call sound. You can't do it on pain of contradiction. Might as well say 2 + 2 is 5. It is equally irrational. Which means just having true premises isn't enough. Mickey's over 6 feet tall, therefore it'll rain tomorrow. You don't accept that conclusion, even though the premise is true, because it's not valid. So a sound argument, as a good deductive argument, must make a good inference, which means with a deduction it's valid, and has all true premises. So notice the question we ask there, once we've determined it's valid, we simply need to ask, are all premises true? So, go back to the Obama space alien example. All Republicans are space aliens, Barack Obama's a Republican, therefore Barack Obama is a space alien. Is it valid? Of course. Are all premises true? Of course not. So the entire evaluation of that argument, and always get in the habit of saying 3 things, you would call that argument deductive, valid, but unsound. Since it's unsound, I don't need to accept the conclusion. By contrast, if you were clever, you probably noticed the Obama example is identical to the Socrates example in form. All men are mortal. Socrates is a man, therefore Socrates is mortal. So it's deductive for the same reason. It's just supposed to follow from the definition of all. Does it? We ask the same inference question. Assuming it were true that all men are mortal, and it were true that Socrates is a man, would it follow that Socrates is mortal? Yes, which makes it valid. But valid's only half of an evaluation. So once it's determined that it's valid, I go and ask, are all premises true? Well, are all men mortal? Yes. Was Socrates a man? Yes. So that example, your three things you should evaluate, you should call that deductive, valid, sound. Why does soundness matter? It's a successful argument, which means we must accept the conclusion. If it's valid and all premises are true, we have to accept the conclusion. By contrast, notice what comes off of the invalid branch of the chart automatically shunts to unsound. Why? Sound argument means good. Invalid argument is a bad inference, therefore an invalid argument is automatically unsound. So you should also get into the habit of, as soon as you write the word invalid, automatically write unsound. So a deductive, valid, unsound argument. Here's one. Mickey's over 5 feet tall, therefore Mickey's over 6 feet tall. Nice simple argument there. Deductive, because it's intended to follow with mathematical certainty. Does it? No. I can imagine a situation where the premise is true and the conclusion is false, i.e. I can imagine if Mickey was 5'6". Given that's the case, the premise can be true without the conclusion being true, so we call that argument invalid, and we call it unsound, even though the premise is true. So the proper evaluation for that argument, like get in the habit of writing three things: deductive, valid, unsound. The next video, we're just going to do nothing but evaluation, so if that's a little fast for you, that's okay. We're mainly trying to learn how to apply and what the terminology means on this video. All right, so sound means a good deductive argument, means a couple of things. You have to accept the conclusion of a valid argument if all premises are true. Which means you have to accept the conclusion of a sound argument. As soon as you call an argument sound, you're saying, I have to, and really everyone has to, believe this conclusion. So if I want to resist a conclusion, I have to call the argument unsound by showing the premise is false. All right, let's pause here before we get to induction and ask, whose job is it to make these calls? Very roughly speaking, and we'll emphasize this a little more next video, it's the job of the logician, or the philosopher if you like, to determine whether an inference is good. So if I want to know whether the conclusion follows from the premises, that's a question for logic. If I want to know whether a premise is true, most of the time, that's a job for the sciences. So it's not philosophy's job to determine if Mickey's over 6 feet tall. So just that's kind of the division of labor. Answering question 3, job of philosophy. Answering question 4, at least with your basic arguments, that's the job of the sciences. We're going to add a little bit to that. Yeah, you know what? Let's add it now, since I've already tantalized you. Call it normal argument evaluation or everyday argument evaluation. That's how it works. If I want to know whether a premise is true or not, I turn to the sciences. What if there are philosophical premises, though? That's a different question. So kind of create this distinction in your mind of a normal argument evaluation, or if you like, non-philosophical or everyday, and philosophical argument evaluation. The terminology works the same, but the difference is whose job is it to tell me, and how do I figure out if the premises are true? So here's an argument you hear sometimes. Murder is wrong, therefore abortion is wrong. So first of all, it's a terrible argument because it's missing a premise. The premise that's missing is abortion is murder. Do the sciences tell us abortion is murder? Nope, absolutely not. Do the sciences tell us that murder is wrong? Nope, absolutely not. And so we can't simply turn and say, what do the sciences tell us about the premises? Instead, here's how we would do that in philosophy, and we're going to see this a lot this semester. Well, after the sciences have told us whether scientific premises are true or false, again using Russell and the science very generally, we turn to the philosophical premises. How do we determine if a philosophical premise is true or not? How do we determine if murder is wrong or not? Roughly speaking, we turn to further argument, subsidiary or supporting argument. And so our job in philosophy is basically to look at all the considerations, this value in indefiniteness stuff that Russell talked about, and say, well, do I have better reason to think that murder is wrong? Or do I have better reason to think that it's false that murder is wrong? Philosophically, I do my evaluation and assign, well, of course, murder is wrong. But then, abortion as murder is also a philosophical premise. And so we would have to look at the philosophical sub-arguments and ultimately ask ourselves, do I have better reason to think that abortion is murder, or better reason to think that abortion is not murder? And my answer to that will tell me whether I should accept that premise as true or not. So in argument evaluation, we tend to think in terms of the scientific premises and the philosophical premises, again, using the very, very general distinction Russell made. The sciences will simply tell us whether a premise is true or not, and we'll see this a little bit next video, if this seems like a lot. And then we turn to any philosophical premises. The question we ask ourselves there is, given the subsidiary arguments and support, do I have better reason to think it's true or false? And we evaluate accordingly. So more on that when we get to the evaluation, but that's the general idea of what's going on. Finally, let's turn to the induction. That's not going to take very long at all, because with a few minor changes, just about everything I said for deduction goes for induction. So look at question 3b. First of all, this is still an inference question, which means I ask, assuming all premises were true, would the conclusion follow, or would the conclusion be supported, etc. And there, the only difference between deduction and induction is what is meant by support. So there's our terminology, is strong and weak. Once more, you could turn to your deductive definitions of validity, make a few minor changes to get to strong and weak. First of all, notice where we are in the chart. We are talking about inductive inference. So that gets us 90% of the way there. A strong argument is a good inductive inference. A weak argument is a bad inductive inference. So strong and weak are technical terms in this course. I expect you to use them accordingly. Beyond that, let's add a few things. So yeah, the approximate definition of strong is good inductive inference, but we can make 3 precise definitions, which should sound very familiar because they're like the definitions of validity, except we replace logic words with probability words. So the first definition of a strong argument is an argument in which it is improbable that all premises are true and the conclusion false. Let me say that again. It's an argument in which it is improbable that all premises are true and the conclusion false. And we should believe what's probable, by the way. That's why these work. Similarly, we could say a strong argument is an argument whose premises make the conclusion likely. Or lastly, we could say it's an argument whose form is usually truth-preserving. Any of those get us to the ballpark. And in terms of what do we mean by an inference. So, again, like deduction, there's the 2 realms shall never meet. First, we evaluate the inference. If the inference is good, we evaluate the content. But evaluating inference is not evaluating content. So just like before, you could have a strong argument that's garbage in a sense. So here's the inductive equivalent of something like the Obama space alien example. So let me just preface this. Everything I'm about to say is false. Mickey Lurkowski, this guy, is the foremost expert on ballet at Kent State University. He has written peer-reviewed articles on the art of ballet. He says the upcoming performance of A Midsummer Night's Dream will be bad, therefore it will be bad. First of all, this is an inductive argument because it's relying on cause and effect, specifically the type of cause and effect about expertise. This is an argument from authority. To determine if it's a strong argument from authority or not, we ask, assuming all premises were true, would the conclusion follow? So in this case, assuming it were true that Mickey was the foremost expert at ballet at Kent, and assuming it were true that he wrote articles about the art of ballet, and assuming it were true he said the upcoming performance of A Midsummer Night's Dream would be bad, would it be likely that it's bad? How do we judge that? I always like to say, would you bet money on it? Would you bet that it will be bad? And the answer is, of course. That's a perfectly good inference from expertise, and so that argument is strong. But again, the problem isn't the strength, the problem is the premises, the factual content. But like validity, if I want to reject the conclusion of a strong argument, I have to reject the premise. Why don't I believe the ballet is going to be bad? Because it's false that Mickey is any of those things or said those things. So that's the inductive equivalent of validity. The only major difference besides what I've already mentioned, arguments are either valid or invalid. A valid argument, the premises make the conclusion 100% likely. An invalid argument, the premises give zero support to the conclusion. By contrast, strong and weak arguments are what are called scaling. An argument whose premises make the conclusion 51% likely is a strong argument, just not very strong. By contrast, an argument whose premises make the conclusion 99.9999999% likely is still a strong argument, just much stronger. So if you're having trouble thinking about probability and why we should believe things, well, it's very probable that your car will start, and so you should believe it. It's very, 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 very probable that the sun will rise tomorrow, and so you should believe it, etc., etc., etc. There's nothing problematic about that, but sometimes that catches people. So validity is all or nothing. Strength and weakness is everything in between. But lastly, we move to the last part of the chart. Notice the language, cogent and uncogent. First of all, like before, cogent means successful. So a cogent argument is what we are aiming for if we're doing induction. So the approximate definition of a cogent argument is a good inductive argument. Once more, that means a couple of things. One, that means we have to believe the conclusion on pain of contradiction. To reject the conclusion of a cogent argument is still fundamentally definitionally irrational. So if I want to reject the conclusion, I have to say the argument's not cogent. And second of all, though, because cogent argument means a successful inductive argument, since every argument has to do two things, a cogent argument is one that has done both of those things well. It's made a good inference and has good content. So the definition of a cogent argument, the precise definition, is a strong argument with all true premises. So just like if I have a valid argument with all true premises, I know the conclusion's true. If I have a strong argument with all true premises, I know the conclusion is true. Just different degree of knowledge. So, definition of a cogent argument, a strong argument with all true premises, and therefore a likely true conclusion, which means I should accept it. Notice, just like before, cogent only comes off of the strong branch. As soon as you identify an argument as weak, automatically uncogent. No such thing as a weak cogent argument. So, that's how we use the terminology. This is a good place before you watch the next video to just kind of pause and see if you could play a little. Here's a good assignment. See if you could come up with arguments that are all the possible combinations, of which there are 6. See if you could come up with an argument besides mine that is valid but unsound, valid and sound, invalid unsound. Notice there's no fourth combination there. Strong and uncogent, strong and cogent, weak and uncogent. Get some, and don't try to stretch your brain. Try to be a little bit blunt with these, because these will serve as kind of good examples to help you get in the ballpark of evaluating. So those are good things to work on, and if you can do that, you're ready to step up and go to the slightly more formal evaluations, which we will have on the next video.